Okay, so circle is named by the center, so this would be circle P. Radius is from the center to the outside. It's halfway across the circle. Diameter is all the way across the circle through the center. Concentric circles, those are two circles that are like one inside the other. Central angle, that is an angle in a circle that comes from the center, so that would be central angle. Semicircle is half a circle, and then congruent circles are the exact same shape, size, and dimensions. So the other ones I was assuming would be probably a little bit newer to you. This whole chapter is based on circles, but there are a lot of new concepts that you haven't seen in regards to circles. So one of the things is common arc, or I mean minor arc is what it says. So let's say from this point to this point, that would be an arc, and minor means that it's less than halfway around. A major arc would be more than halfway around the circle, like that. And then inscribed angle, so inscribed means on the inside of the circle. So an inscribed angle would look like this. Okay, and then moving up here, inscribed polygon. Again, inscribed means on the inside of the circle. So if you have a circle, an inscribed polygon might look like this. It's like a polygon. This would be a triangle inscribed in the circle. And then circumscribed circle, that would be on the outside. So in this case, circumscribed circle would be this part. And then circumscribed angle, again, outside. The angle's on the outside, so it would look like this. Okay, we're going to move over to the next page. There is some more vocabulary I'm going to bring into the picture. So over here, I'm actually going to zoom in as well. Okay, so on this page, we have circle, which you should be familiar with, diameter, radii, which is just plural of radius, and then the newer words would be chord, secant, and tangent. So we're going to start with the words we know. It says name the circle. You name the circle based on the center. So this would be circle C or circle C. And then two radii. So radius is from the center to the outside. So like segment CD or segment AC, those are both radii. And diameter through the center all the way across. So a diameter here would be segment AD. And then we'll go into the vocabulary that you haven't seen before. So here it says name two chords. Now, first of all, what is a chord? A chord is a segment with endpoints on the circle. Segment with endpoints on the circle. So what would that look like? Okay, so here's a circle. Be like AB. That would be a chord. So technically the diameter is a chord, but a chord doesn't have to be through the center like diameter does. So name two chords here. Might be segment HB and also segment AD, the diameter. Okay, and then secant is another new word. Secant is a line that intersects the circle at 2 points. Line that intersects the circle at 2 points. So if you have a circle, a secant looks like this. And in our diagram, a secant would be like line KG. And there's also practice on this on Alex too. And then the last word that's new is tangent. A tangent line intersects the circle at 1 point. Line that intersects the circle at 1 point. So like if you have a circle like this, a tangent line looks like this. It just hits the side at one spot. And then it says name a tangent line and a point of tangency. So the tangent line right here would be line GE. And then the point of tangency, which you may like predict, is just where it intersects, which would be point F. Okay, so we're not going to do this bottom portion, but we're actually going to jump back to the start, like the beginning page. We're going to go back to where it says chapter 10 cheat sheet. I'll zoom that too. Okay, so chapter 10 cheat sheet, this actually has all the theorems or like the math rules that we're going to use. So that way you don't have to like write them out every time. The two that we're focusing on today are right here, tangent theorem and tangent segments theorem. So the first one here, it says in a plane, a line is tangent to a circle if and only if I'm saying this already, to a circle if and P only if the line is perpendicular to a radius of the circle at its point of tangency. Is there a typo in that, or did I just like say it wrong? I don't know. Okay, this right here is shown right here. This would be the tangent line. And what they're saying is if you have a tangent line, it would be perpendicular to this radius here. So it makes a 90-degree angle. And then the second theorem is tangent segments from a common external point are congruent. And what that means is in this diagram right here, you have this external point right here and two tangent lines. These tangent lines are the same length. Then from here, we're going to jump back to where we were and then apply this to the problems. So here we have this, and then flip one more page to this. Okay, so we just learned that if we have a tangent line like this, it is perpendicular to the radius. So for 11 through 14, it says, tell whether segment AB is tangent to circle C. Explain your reasoning. Well, if AB is tangent, then this would make a 90-degree angle here, and then we'd have a right triangle. So we're actually going to use a squared plus b squared equals c squared to prove that AB is tangent. So we'd have 6 squared plus 8 squared. Does that equal 10 squared? Does that equal 100? Yes, it does. So therefore, yes, AB is tangent. Then number 12. So same thing, if AB is tangent, that should be a 90-degree angle. So 9 squared plus 15 squared. Does that equal 18 squared? This one is a no. So since this doesn't equal this, then AB is not tangent. We're not going to go through and solve 13 and 14, but sometimes what they do is they leave out parts of the segment. So for example, it shows the radius here is 20, but you need this whole thing. Well, this would also have to be 20, and sometimes you have to add that up to get that length. Or like in 14, they show you this is 12, but they don't show you this length. Well, the radius, no matter where it is, should be 12, so this would be 12 as well. And then you can add stuff up if needed. Okay, we're going to cross out this bottom portion and skip to the next section. Okay, so over on this page, we're specifically focusing on this bottom portion here. So remember, we saw that if you have two tangent lines from the same external point, then these two segments are equal. And it says to find the value of x. So the way we are going to find the value of x is setting these statements equal. 2x plus 7 equals 5x minus 8. And then we'll solve for x. We're not going to do too many of these because they're all about the same. But we'll do 25. Again, same setup. Two tangent lines are equal, so 4x minus 7 equals 3x plus 2. And we can just solve for x. And that's all. So at this point, you're going to do homework 10-1 on Schoology. If you need any help, let me know, but it should be pretty straightforward. You might want to keep your notes out and then work on your weekly Alex. And the lab tests are back there. You can go ahead and grab them.